This will just be a quick video about me explaining what the mean value theorem is. And keep in mind, you want to pay attention to this because it's a free point on a test if you know what this is. So basically, let's talk about the conditions of the mean value theorem first. So the conditions are your function must be continuous on the interval and differentiable on the interval. Oh my god, I spelled that wrong. Differentiable. I always spell that wrong, I'm not gonna lie. Technically, there's only one condition, because if you're differentiable, you must be continuous, but I'm just going to state both. So, what does the mean value theorem state? Well, if you pick any 2 points on this graph, let's pick this point, and you find the slope of the line between them. So, the slope of the line between them, let's say this is the line between them, it's the secant line, that's the mathematical term, but if you find the slope of the line between them, there must be a point on the graph between these 2 points, so there must be some point anywhere between these 2 points within the interval of these 2 points where the derivative is equal to the slope of this, where the derivative is equal to the slope of this secant line. So this secant line slope is equal to some derivative along this function. In between these 2 points. It has to be in between. It can't be outside the points. That's what the mean value theorem states. And if I were to draw an example of this, maybe this point looks like it has the same slope. So the derivative, or the slope of the tangent line, must be equal to the slope of the secant line. I mean, like, these slopes kind of look similar enough, right? So this is an example of a point between these 2 points where the derivative is equal to the slope of the secant line. Now, keep in mind, this must be differentiable and continuous. So, if you have a function that has sharp turns, like this, okay? And you pick 2 points between these, and you find the slope of the secant line. Since this function is not differentiable, it does not meet the conditions for the mean value theorem. It's not differential along the between the interval, at least, between these 2 points. So, if you were to try to find some point that had the same derivative, the same slope or derivative as this secant line, you couldn't, because maybe the slope of this entire linear line is 1, and the slope of this entire linear line is -1, but the slope of this secant line is, I don't know, -1/2. Right? You're not going to find a derivative that's -1/2 along 2 straight lines if their slopes are already defined. So keep in mind, differentiability is very important. But basically, that's it for the video. Slope of the secant line, as long as the function is continuous differentiable, is equal to some derivative of within the interval of your 2 points. Goodbye.